Hello guys, welcome to my Python tutorial. In this video, we are going to talk about set, frozen set and possible operations on set. A set object is an unordered collection of distinct hashable objects. In Python, any immutable object such as integer, boolean, string, tuple is hashable, meaning its value does not change during its lifetime. This allows Python to create a unique hash value to identify it, which can be used by dictionaries to track unique keys and set to track unique values. Common uses of sets include membership testing, removing duplicates from a sequence, and computing mathematical operations such as intersection, union, difference, and symmetric difference. Like other collections, sets support x in set, len of set, and for x in set. Being an unordered collection, set do not record elements' position or order of insertion. Accordingly, set does not support indexing, slicing, or other sequence-like behavior. There are currently two built-in set types, set and frozen set. The set type is mutable. The contents can be changed using the methods like add and remove. Since it is mutable, it has no hash value and cannot be used as either a dictionary key or as an element to another set. The frozen set type is immutable, unhashable. Its contents cannot be altered after it is created. It can therefore be used as a dictionary key or as an element of another set. We can create an empty set by using set constructor only because empty curly braces will create an empty dictionary. We can create a set of elements by enclosing comma separated values in curly braces. As it is not in form of key value pair, it is considered as a set. We can use len, range, min, max and membership operators on a set. Now, brushing up the basics of set theory, consider three sets, set A, set B and set C, where set A contains 1, 2 and 3, set B contains 1, 2, 3, 4, 5 and 6, set C contains 6, 7 and 8. Now, set A is subset of set B as every element present in set A is present in set B as well. And now we can say that set B is superset of set A, and union of n sets would return a set by combining elements of n sets, removing the duplicate elements. Intersection of n sets would return the set of one or more elements which are present in all the n sets. Difference of set A and set B would return the element present in set A and not in set B. Symmetric difference of two sets would return the set of elements in set A or set B but not in both. Now let us begin our practical session. Let us see how to create a set. We use the set constructor to create a new set, and to populate it with values, we use add function. Set is unordered, so we cannot predict where will the element be stored. So we just give add of element without any index. Set can take any iterable as an input, but add can take only one element. We use remove method to delete elements from set. Membership operators in set, max, min can be applied on set. Len and range can be applied on set as well. Indexing is not possible in set. We obtain an error which says set object is not subscriptable when we try to access the element of a set using index. Now moving on to set operations. Let us begin with disjoint set. When the function is disjoint, it takes exactly one argument, which is a set, and returns a boolean value depending upon whether the sets are disjoint or not. We now have is subset, which is used to find whether set A is subset of set B. This returns true even if two sets are equal. Now the operator equivalent of subset function is less than or equal to, which is exactly same as is subset function, and we have less than operator which returns false when the two sets are equal, as it checks only less than and not for less than or equal to. Now we have is superset function, which checks whether set B is superset of set A. This function also returns true if both sets are equal. The operator equivalent of is superset is greater than or equal to, and greater than will return false when two sets are equal. We can obtain union of two sets by using union function. which can take any number of sets as input. An operator equivalent of union is bitwise or symbol, whose functionality is precisely same as that of the union function. Similarly, we have intersection function, which takes n sets as input. Operator equivalent of intersection is bitwise AND. Now we have difference function whose operator equivalent is minus sign, which is a demonstration of operator overloading, which we have discussed already. I have provided the link for the video in my description box. Symmetric difference, on the other hand, can be obtained using symmetric difference method, whose operator equivalent is exponent sign. Copy method creates a shallow copy of a set. Moving on to the frozen set, it is similar to set with the only difference being immutable. So certain functions of set which alters the set is not applicable in frozen set. I have implemented these functions in Jupyter Notebook. I have also provided the link in my description box. Here is the most awaited moment where we talk about the application of set, which is plagiarism detection, where intersection of two sets is obtained, which is divided by the length of the set to see which extent the content is redundant. We also have other factors like longest common subsequence to produce the complete output for plagiarism detection. So that's all about set and frozen set in Python. See you guys on my next video. Thank you.